and welcome back to NUS High's Math Interest Group YouTube channel. Today, we will be talking about functions. Firstly, what is a function? Well, a function is a special type of relation where each element in the domain, which is the set of all possible inputs, corresponds to only one element in the codomain, the largest allowed set of outputs. So these are two ways that I can show the function f of x equals to x squared plus 1. But what does this mean? So firstly, each function has a relationship between the inputs and outputs known as the role. So in this case, the role is fx equals to x squared plus 1. The domain is the set of all possible inputs, in this case all real numbers, and the codomain is the largest allowed set of outputs, in this case also all real numbers. The range is the set of all possible outputs which is based on the domain, in this case from 1 to infinity. I would like to talk about inverse functions, which are a type of function which takes in the set of all possible outputs, the range, from the original function and maps it to the corresponding input in the original domain. However, not every function has an inverse. Only bijective functions have inverses and vice versa. A function is bijective if and only if it is both injective and surjective. An injective function has each element in the range correspond to a unique input in a domain, and the surjective functions have the codomain equal to the range. The graph of the inverse function f inverse is the reflection of the graph of f about the line y equals x. Also, the domain of a function f is the range of f inverse, and the range of f is the domain of f inverse. The inverse of the inverse function is also the original function.
Now, let's introduce some types of functions. First, we have linear functions, f of x equals to x, or 3x minus 8, or 288.5x plus pi squared over 6. The thing about linear functions is, when their graph is drawn, it is a straight line. Then we have quadratic functions, x squared and minus 2x squared plus 4x minus 900 root 2. Quadratic functions are defined by their highest power of x being x squared. Then we have polynomial functions. They are like quadratic functions, except they don't have a restriction on their highest power of x. For example, here we have x to the power of 100, and also we have one that has no power of x inside, which is f of x equals to 1 and f of x equals to 0. We also have rational functions, which are a polynomial divided by another polynomial. Then there are the trigonometric functions, f of x equals sine x, cosine x, tangent x, and so on, and some of their inverses as well, inverse sine and inverse tangent. Exponential functions, f of x equals e to the x, to the x plus 1, and half to the power of x. And finally, logarithmic functions, the natural log of x, log base 2 of x, log base 5 of x minus 1. Notice that some of these, for example the natural log of x, don't take all the real numbers as their input. Natural log of -1 is not defined. So in these cases, we just set the domain to be all the real values where they are defined. Here we have some other examples of functions. The first one here is defined from the non-negative real numbers to the non-negative real numbers and maps x to its square root. The second one here maps real numbers to non-negative real numbers and maps x to its absolute value, which is what you get by removing the plus or minus sign in front. Finally, we have this function, which is a piecewise function. It's defined in two parts. If x is not equal to 0, then f of x is equal to x, and we also have that f of 0 is equal to 529. Here are some applications of functions. The first is a Celsius to Fahrenheit conversion. If we give the function an input of x degrees Celsius, we get an output of 9 over 5 times x plus 32 degrees Fahrenheit. The second is to calculate the area of a circle. f of the radius is equal to pi r squared, which is the area of a circle with radius r. The second two are a bit different. Here we have a function mapping a date to the day of the week. You can code this on a computer, and it's a useful function whenever you need to do stuff with dates. And here's a different one, where we give it a date and it gives you the forecasted temperature on that date.
Hey guys, I'm Shihong and I'll be talking to you about Desmos. You can get there by searching Desmos graph, clicking on the first link, or by entering this link. Desmos allows you to graph different things like linear graphs or polynomial graphs of any order as long as it doesn't crash. Like this, for example. You can graph exponential graphs, or maybe if you want to do it in a different way, stuff like that. You can create sine graphs like that, or even circles. That's a circle of radius 6, and you can add a variable, and there will be an add slider button. You can click it to add a slider and change its bounds like that. And that's all from me. I'll pass my time on to Unhan.
Now I shall demonstrate how we can use Desmos to visualize transformations of graphs. So here I have a blank graph, and the first thing I'll do is create a function f of x to be, let's say, x squared. And I'll create another variable to represent a real number, a. Now I shall plot y equals f of x minus a. What we notice is that when we increase the value of a, our graph shifts over to the right. And we notice that our graph shifts over by exactly a units. So what this leads us to conclude is that y equals f of x minus a is actually a shifted version of y equals f of x to the right by a units. Similarly, when we replace the negative by a positive, we notice that our graph is actually over to the left now and by the same amount. So what this leads us to conclude is that y equals f of x plus a is actually a shifted version of y equals f of x by a units to the left. Now I shall plot y minus a equals to f of x. We notice that a similar thing occurs, and y minus a equals f of x is a shifted up version of f of x by 3 units. Similarly, when we replace minus with a plus, we notice that our graph shifts down, and y plus a equals f of x is actually a shifted down version of y equals f of x by a units.